Hello everyone, welcome back to mathsmood. Here we have interesting exponential equation in trigonometrical form. We have 81 to the power sine square x plus 81 to the power cosine square x equal to 30. On the first side, this equation is real hard because we have all different bases, we have all different exponents, and in a trigonometrical form we have squares, but we can simplify this a little bit, and for sure we can solve this in 4 or 5 minutes, so let's check it out. Okay, first of all, we can represent this 81 as 3 to the fourth power. Just simplify it a little bit. So 81 is equal to 3 to the fourth power. So let's put this 3 to the fourth power right here. So I will have 3 to the fourth power raised to the power sine square of x plus 3 to the fourth power to cosine square of x equal to 30. Just put this 3 to the fourth power right here. Okay, what are we gonna do next? We know that this we can write as multiplying these powers, so we can write it as 3 to the power 4 sine square x plus 3 to the power 4 cosine square x equal to 30. I'm not gonna write this rule, but this is pretty simple, so let's go next. So we have this equation and we just simplify this a little bit, but we can write this cosine using the sine square x. We know that sine square x plus cosine square x equal to 1. This is a trigonometrical rule, so we can use this. For sure, we can represent this cosine square of x using this sine square of x. So cosine square x equal to 1 minus sine square x. So let's use this right here. So let's put this instead of this cosine square x. So we will have 3 to the 4 sine square x plus 3 to the power 4, and just put this cosine square of x right here. So instead of cosine square x, I will have 1 minus sine square x equal to 30. We can multiply this for sure. 3 to the 4 power sine square x plus 3 to the fourth power minus 4 sine square x equal to 30. So we have this power 4 minus 4 sine square x, and we can simplify this a little bit because we know the rule. If we have a to the power m plus n, it will be equal to a to the power m times a to the power n. So we can break for sure this exponent using this rule. So let's do this. Okay, we will have 3 to the power 4 sine square x plus 3 to the fourth power times 3 to the power minus 4 sine square x equal to 30. So we just break this exponent. For sure, we don't need this minus right here, so we can write this 3 to the 4 sine square x in our denominator. So let's do this. 3 to the power 4 sine square x plus 3 to the fourth power, and for sure over 3 to the power 4 sine square x, because we have minus in our denominator, and for sure we can throw this value in our denominator, and it will be equal to 30. We have 3 to the power 4 sine square x, and for sure 3 to the power 4 sine square x the same, so we can use a substitution. So let 3 to the power 4 sine square x for sure equal to, for example, y. And let's do this substitution. So we will have an interesting equation. Y plus 3 to the fourth power equal to 81 over y equal to 30. just put y instead of 3 to the power 4 sine square x. So let's multiply both sides by y. I will have y squared minus 30y and plus 81 and equal to 0. We have a really good quadratic equation, so let's try to solve this. The sum y1 plus y2 equal to 30 and the product y1 times y2 equal to 81. So let's find these roots. For sure it will be y first, it will be equal to 27, and for sure y second it will be equal to 3. So we have two roots, so for sure we will have two equations. Let's write the first one. We will have 3 to the power 4 sine square of x equal to 27, and the second one we will solve this a little bit later. So let's start with the first one. 3 to the power 4 sine square of x equal to 27. For sure we can express this 27 as 3 cubed, so let's do this. 3 to the power 4 sine square x equal to 3 cubed. For sure we have same basis, so we can write an equation with our exponent. 4 sine square x equal to 3 sine square of x equal to 3 over 4, and our sine x equal to square root of 3 over 2. So we have a table case, so let's write a solution to this. So we know that sine x equal to square root of 3 over 2, it will be equal to p over 3. So let's write a general solution to this. So we will have x equal to minus 1 to the power n arcsine square root of 3 over 2 plus pn. N is z. So let's simplify this. We know that this arcsine square root 3 all over 2, it will be equal to p over 3. So the first solution to this, x1, it will be equal to minus 1 to the power n times p over 3 plus pn. N is z. So this is the first solution to our equation. So let's find the second solution. We know that we will have the second equation, 3 to the power 4 sine square x equal to 27. We solve this and equal to 3. So this is 3 to the first power. We will have 4 sine square x equal to 1 sine square of x equal to 1 over 4. Just divide both sides by 4. So the next step, let's take square root from both of the sides. We will have sine x right here, and right here we will have square root of 1, it will be 1, and square root of 4 equal to 2. So for sure it is the table case, and we can solve this using this logic. So x will be equal to minus 1 to the power n arcsine 1 over 2 plus pn. N is z. And for sure we can simplify this a little bit. This arcsine will be equal to p over 6 30 degrees. So the second solution, x2, will be minus 1 to the power n times p over 6 plus pn. N is z. So this is the second solution to our equation. So this equation is really interesting. We learn a few tricks with our exponent, this, and we learn our trigonometric equation, which is really good for us. And for sure we remember, or we learn table cases with our trigonometrical equation. So If you like this solution or if you have any suggestion, write your suggestion in a comment, and thank you for watching and see you in the next videos.